Fourier series. These are really the workhorses of our analysis of partial differential equations. And so finally, here is one. So what I'm going to do is I write f of x to be the sum a0 plus the sum n is 1 to infinity an cosine n pi x divided by L plus bn sine n pi x divided by L. So I would like to write f as a trigonometric series. And we do have indications already that this actually might work. So let me go back one page. So here in the previous page, we discussed the inner product of functions which are piecewise continuous, PWC. And the inner product is just the integral f of x g of x dx from a to b. And then we saw if we choose particular functions cosine and sine, then these turn out to be orthogonal. So for example here, if we have the C0 function, if we integrate this with each other, so 0, 0, comma C0, we get 2 times the domain length. And the length, I should say that as well, is right here. This is the difference b minus a divided by 2. Now if we take cosine functions with different n and different m, then we get 0, right? So here we have Cn and Cm, so cosine with an n, cosine with an m, and we get a delta nm times the interval length L. So this certainly also means Cn, Cm is 0 for n is not equal to m. So only if they are the same index we get something, and the something which we get is L. Same is true for the sines. If you multiply the sine with different index, you get 0. With the same index, you get L. And then the mixed ones, sine and cosine, they're always 0. All right, so this means the set of all these sine and cosine functions is an orthogonal set. Meaning the representation, again, back here to my Fourier series, is an orthogonal representation of f in the space PWC. Of course, this raises a whole bunch of questions, and here are 3 of them. How do we find the coefficients a0, an, and bn? And this is something I will answer right now in this video. And then once the constants are found, when does a series converge? This is something I will do in 2 videos from now. And then if it converges, does it converge to f? But question 1 we can do. How to find these coefficients a0, an, bn? For this I write again the Fourier series, but now I use a shorthand notation with the Cn and the Sn, right? So Cn is this guy, and Sn is this guy, so Cn is a cosine, Sn is a sine function. And since I know so much about orthogonality, that's what I'm going to use. So what I do is I multiply f with the function C0. Actually, C0 is the constant function. I need to show this once more. So this guy here is actually C0, which we symbolized with a 1. So C0 multiply with f in the inner product. This means I take the representation of the series and multiply this with C0. And now this inner product is linear, so I can do it component-wise. So I multiply the C0 term first, and then the Cn term here, and then the Sn term there. Okay, and then so I get 3 inner products. And I know that these guys will be 0. This is 0, and this is 0, which is something we have shown before. Only with the same index we get something, and in this case we get 2L. So we get 2L from the first term, and of course we keep the coefficient a0. But then we can solve this for a0. We find the coefficient then to be the inner product f with C0, and then multiply it with the 1 over 2L. So if we know f, we can indeed compute a0 by just doing this one integration. How about for the other c's and for the other a's and b's? Well, now we multiply f with cm, so which is cosine m by x divided by L. Again, I write this as a Fourier series, multiply this with a cm. Linearity allows me to multiply the C0 with a cm and this cn here with a cm and the Sn here with a cm, and again, right, the brackets denote the inner product, which really is an integral, but I don't have to do the integral because we did it already. So now the first two will be 0, they have a different index, 0 and m, and these guys will be 0 because they have a different sine and cosine involved. So we only keep part of here, which is delta nm, so it's only 1 if n equals m, times the domain length L. And this is what I have here. Everything else is 0. The sum really trickles down to only one value, which is am times L. Ooh, this is cool. So then I can compute am like this. And now I'm pretty sure you could do the same calculation where you substitute sine here as m instead of cm. The whole thing trickles through the very same way, and you get the b's. You get the bm is 1 over L f multiplied with sm. Oh, that is very cool. So let us summarize this here in this little definition of a Fourier series. Yeah, fits all in one page. So the Fourier series has the coefficients a0, an, and bn. It is a sum of cosine and sine terms. The L needs to be associated to b minus a over 2. And then we can compute a0, an, and bn. So a0 would be 1 over 2L, the inner product of f with c0, which is the integral here. An is the inner product of f with cn, the cosine terms. The bn is the inner product of f with the sine terms. And all multiplied with 1 over L. Now, these are a whole bunch of formulas, but these are actually formulas you need to know. Students often ask, which formulas do I need to know for the midterm and the final? Here you go. You have already 3, or maybe if you do this one, you have 4. And then this is called Fourier series, and these ANs are called, and the ANs and BNs are called Fourier coefficients.